Hello, and welcome to lesson 11-1, which is on congruent triangles, congruent transformations, and we're going to be doing a lesson called Trust Your Judgment. Bottom, bum. Okay, you have two learning targets. One of them is to use the fact that congruent triangles have congruent corresponding parts. So corresponding is kind of a throwback vocab word to Module 1. When you had corresponding angles, they were the same but in a different location. So we're going to build on that vocabulary word today. And then we're going to determine unknown angle measurements or side lengths in congruent triangles. So remember, congruent means two triangles that are the exact same side, and same shape. All right, so let's take a look at our problem. All right, Greg Carpenter is his last name, works for the Green Construction Company. The company is building a new recreation hall, and the roof of the hall will be supported by triangular trusses, like the ones shown below. And this is actually true. I did a Habitat for Humanity build, and this is what the trusses of the house look like. Okay, so let's take a look at connection to career real quick. It says triangles are often used in construction for roofing and floor trusses because of their strength and rigidity. Each angle of a triangle is held solidly in place by its opposite side. That means that the angle is not going to change when pressure is applied, unlike other shapes. So this is interesting. Triangle is like the strongest shape, which is why it's used often in building bridges, etc. All right. Each of the trusses contains pairs of congruent triangles. Greg's boss tells him that his first job is to determine the side lengths and the angle measurements in the triangles that make up one of the trusses. Okay? So one more math tip. Congruent triangles are triangles that have the same size and the same shape. More precisely, you have seen that two triangles are congruent if and only if one can be attained from the other by a sequence of rigid motion. That's like a plug to rigid motion in Module 2. So basically when I move something, when I flip it, when I rotate it, I'm not changing its angles. Okay, so it's got rigid motion. All right, so let's take a look at these trusses on the next page. Greg is wondering, if I know that two triangles are congruent, and I know the side lengths and the angle measurements in one triangle, do I have to measure all the sides and the angles in the other triangle? So Greg is trying to do less work. So he doesn't want to measure every single one of these triangles. If he figures out part of it, he's saying it's a reflection. So can I use that knowledge of congruent triangles to save him some time? So Greg begins by examining two triangles from a truss. According to the manufacturer, the two triangles are congruent. Okay. All right, so I have triangle ABC and I have triangle FED. Okay, because the two triangles are congruent, one triangle can be mapped onto the other. Can one triangle be mapped onto the other? If yes, what is the criteria for the mapping? Okay, so remember this kind of looks like a reflection. All right, so each triangle can be mapped onto the other triangle by a sequence of rigid motions. So yes, okay, so this one would be a reflection. So A would be mapped onto D, B would be mapped onto E, and C would be mapped onto F. Okay, so if two triangles are congruent, yes, you can map them onto each other because of rigid motion. All right. So let's assume that we have found a sequence of rigid motions, aka a reflection, that maps triangle ABC onto DEF. Find the image of each of the following under the sequence of transformations. Okay, so what this means is segment AB, which is this part of my triangle, what is it going to be mapped onto? And now if I flip it over, AB, notice they start at the bottom and went to the top, so I'm going to have to do that over here. So AB would be mapped onto DE. Okay, because A and B are in the same corresponding positions in the other triangle. BC, I went from the top to the bottom, so that's going to be EF. And then lastly, AC, it went from left to right, so it's going to be flipped and it's going to go from right to left, so DF. Okay? So those are the matching of the corresponding sides. All right, the angles are a little bit easier. So A, we know is the same as D because it was reflected. So angle A is going to go to angle D. Angle B, the top angle, is going to go to the top angle, so angle E. And last but not least, angle C is going to go to angle F. Okay? So that is how we can look at a picture up here and tell the corresponding angles and sides of which ones can be mapped onto each other. There is an easier way, and I'm going to show you that right now. So this right here is called a congruent statement, and it tells you like a diagram, an instruction, a rule of what happens. So for example, A is the first letter, D is the first letter, they're mapped. Okay, so the first letter goes with the first letter over here. Same thing, B is in the middle letter here is E, so B is mapped onto E. They're in the same position in the triangle. Same thing here, C and F, they're the last letters, they're mapped together. You can also do it with the sides, it's a little bit trickier, but AB is the first two letters. The first two letters in the other triangle are DE. It worked out. Same thing, BC, get a different color. BC are the last two letters. EF are the last two letters. It matched. And then last but not least, you can do the first and the last letter. The first and the last letter. So AC matches to DF. Okay? So if you don't have a picture, but they give you like a map of directions, that's how you can find the corresponding parts as well. Okay. All right, let me know if you have any questions on that. Otherwise, you're all going to try number 3. So what is the relationship between AB and DE? What is the relationship between angle B and angle E? And then tell me how you know. So what do you think the relationship is between those sides and those angles, and tell me what you think. Press pause. So I said they were congruent, okay? So I said that AB was congruent. You could have written out the word congruent too. So they are congruent because there's a sequence of rigid motion that maps them onto each other, okay? So they are congruent because there is some sequence, we talked about reflection, of rigid motion that will map them onto each other, okay? So put that in your own words. All right. Pause that if you need to continue writing down, otherwise I'm going to move on. All right. Move my face. Okay, so let's talk about the triangles from the truss that Greg examined illustrate an important part about congruent triangles. In congruent triangles, corresponding pairs of sides are congruent and corresponding pairs of angles are congruent. These are known as corresponding parts. Okay, so basically saying the sides that match up are the congruent, the angles that match up are congruent, and they're called corresponding parts. So they correspond from one triangle to the other. When you write a congruent statement, for example, like triangle ABC is congruent to triangle DEF, you write the vertices so that the corresponding parts are in the same order. I kind of talked about that. So from that statement, it's revisiting what I just talked about. The first two letters are equal to the last two letters. First two letters equal to the first two letters. The last two letters are equal to the last two letters, okay? So a congruent statement tells you 6 pieces of information. It tells you the 3 sides that are equal, and then it tells you the 3 angles that are equal. All right, let's look at this math term. Corresponding parts result from a one-to-one matching of sides and angles from one figure to another. Kind of like flipping it onto each other. Congruent triangles have 3 pairs of congruent sides and 3 pairs of congruent angles, okay? So again, you can know 6 pieces of information. All right, moving on. So let's look at an example problem. So Greg has done some work and he measured out how long some of the pieces were, and he also measured out the angles of our triangles, okay? So he knows that triangle JKL, which is here, JKL, is congruent to triangle MNP, okay? So remember, J and M are going to be the same measurement based on that ordering up there, okay? Greg wants to know if there's any additional lengths or measures that he can determine, okay? So since he knows these triangles are congruent, he knows that KL has to be the same as NP. So here is KL. I know KL is 2.1. So then I can know the other corresponding side in the other triangle. So KL is the last two letters over here, N and P. So I know that this also has to be a 2.1, okay? So he has found out that NP is also 2.1, all right? So whatever is true in the left part of the triangle is going to be true in the right part of the triangle. All right, what else information he knows? He knows that angle N, I believe that's angle N. Yes, angle N, I know is 50 degrees. N corresponds with, let's figure it out, it's the middle letter, so it's going to correspond with the middle letter over here. So N is the same as K. So since I know they're congruent, they're equal, and so I also know that the measure of angle K has to be 50. So if N was 50, so is K. Okay? So if you have two congruent triangles and you have a congruent statement and you know information about one, you can go ahead and copy and paste that over to the other triangle. Just make sure it's in the same spot. All right? Let me know if you have any questions on that. Otherwise, you're going to try an example. Okay? So I have two congruent triangles. They're letting you know right now that they're the same. So it wants you to find each of the following information if possible. So maybe it's possible, maybe it's not, but see if you can tell me the measure of angle X, the measure of angle T, the length of YZ, and the length of XZ. And then go ahead and try E as well. So it says that they're equilateral triangles and the measure is 60. Can you tell if they're congruent or not? Okay, so try A, B, C, D, and E, press pause, and then we'll go over our answers. It was not possible to find the measure of angle X because I did not know the angle measurement of the other corresponding angle. So I kind of did some color coding to help us out. So R was the first letter, X was the first letter. I don't know anything about X, I don't know anything about R, so I can't figure anything out. Okay. Measure of angle T is going to be 47, so T was the first letter, last letter, sorry, Z was the last letter, and since Z was 47, then I also know T has to be 47. Okay. So you can kind of draw some angle markings and color code to help you out to find your congruent angles. All right, the WYZ. YZ was the last two letters. Last two letters over here are ST, and since I know ST is 15, then I know that YZ also has to be 15. And then last but not least, XZ was not possible. So X and Z was the first letter and the last letter. First letter and last letter is RT. I know nothing about RT, so since I know nothing about the corresponding sides, I can't figure out anything. Okay? All right, let me know if you have any questions on finding missing angles and sides from two congruent triangles. Otherwise, we're going to move on to our last one, which is a bit tricky. So I know equilateral triangles are where each triangle is 60. So 60, 60, 60, that'll get you to 180. Can you tell if they are congruent or not? And the answer is no. So not all equilateral triangles, or all equilateral triangles have the same angle measurement, but they can have different sides. So let me draw you an example. So I can have a very big equilateral triangle where it's 60, 60, and 60. So all the sides are also the same. So let's say these are 10 inches, 10 inches, and 10 inches. Okay, now we know from Module 2 I can dilate that shape and make it smaller, but I'm not going to change the angles when I dilate something. So I can also have a very small equilateral triangle with 60, 60, 60. But I've made my triangle smaller, so maybe this is only 1 inch, 1 inch, 1 inch. Okay, so just because it's an equilateral triangle, you do not know that it is congruent because it can be a big triangle, it can be a small triangle. Okay? All right. Let me know if you have any questions on congruent parts and corresponding parts of a triangle. But that's it, and thanks for watching. You can practice.